Hello, welcome to another screencast. In this screencast I will show you how to do all the visualizations in SPSS. The visualizations can be found in the graph menu and then going all the way down to legacy dialogues. Here you see the many different options that are available to you. Of all these options, we need you to be able to do the bar chart, the pie chart, the box plot, the scatter plot, and the histogram. So most of these graphs you are already familiar with, and you can't recognize them by their fancy names. Let's start off with the simplest one. That's the pie chart. The pie chart, you just ignore this, press define. The pie chart is a representation of particular scores in a big pie. Basically, it's your frequency table and then visual. Well, it's suitable for nominal variables. So, for instance, gender is something we can show with a pie chart. We select the variable that we want, we press a little arrow thingy and we move it here. Pie is made out of slices, so slices. We also want to have percentages. Then we press OK and we get a nice big fat pie. 50% of all the people who participated in this questionnaire were male and 50% were female. By the way, this is not obligatory in any way to have exactly half your data set be men and the other half be women. This is just a weird random coincidence that is exactly split down the middle. It's not a requirement for your data set. If you want to add percentages, you just double click the thing, then you get an editor like this. You can add elements like show data labels and then get rid of this and it shows the 50%. But you already knew this, but from the face of it, it's clear. Again, do not export this into your report. Take the frequency table that leads to this data, put that in Excel, and then use Excel to improve it. This is just how you quickly inspect data in SPSS. After this, and after looking at other variables, you need to ask yourself the question, okay, do I want to put this in my report? Can I use this to tell a story, to answer my main question? Next up is the bar chart. Same menu. Bar. We'll start with the simple bar chart. The simple bar chart can be used to describe scores for ordinal variables. Like for instance on education, which is an ordinal variable. Again, I select percentage of cases and I press OK. Then I get a bar chart. Also, this is similar to what we saw earlier in the tables. Hopefully you saw that screencast about the tables. The distribution of people across these different categories. So about 20% has a high school diploma, 50% a bachelor diploma, and 20%, a little bit more, has a master diploma. You can also try to look at this in a pie chart, but it's less easy to compare the slices of a variable that has many levels. So the more levels you have, the less informative a pie chart becomes. So that's often the case when you're having an ordinal variable. It often has more than 3 categories. So if you have 5 categories, it makes much more sense to do a bar chart instead of a pie chart, because with 5 slices in a pie, it becomes difficult to look at them. Now let's focus on the other option for bar chart, which is clustered bar chart, where you can compare, for instance, the scores for an ordinal variable with scores on a nominal variable. Here you see the scores that we see here as well. Scores for education, so how many people are in a group, split by gender. So we can see in blue all the females, all the women, and in green the males, the men. And we can see in which group there are more men than women, or vice versa. This way, with a clustered bar chart, you can quickly compare two levels of a particular variable that you want to compare. So that was the pie chart and the bar chart. Next up is the histogram. The histogram is sort of a bar chart, only for higher level variables. So a variable that has lots and lots of answer possibilities. Here we have answer possibilities running from 1 to 10, and we can see how often each option occurs. So here for the grade for Nick Fury, we see that people have given, frankly, quite a lot of negative grades. And this is a histogram. It shows you the frequency of each answer possibility occurring. And this is a representation that is useful for interpreting higher measurement level variables. What you want for those variables is a histogram that sort of looks like a normal distribution, so that has this nice bell shape with lots and lots of values in the middle and only few values at the end. You don't get that if you have a bunch of extremists filling in your questionnaire. But let's put that aside. There are other graphs that we should look at. So we've done the bar chart, both versions, simple and clustered. We've done the pie chart. We've now done the histogram. Still left are the box plot and the scatter plot. Let's first look at the box plot. The box plot combines several measures of dispersion and one measure of central tendency into a single graph. In this way, you can look at the distribution for that particular variable, and you can judge it and compare it to others. For instance, if you want to compare how the opinions on the Hulk are different between men and women, you could do it like this. So you want to compare the scores on the Hulk between men and women. You use a box plot. So you get this thing with hooks and a big bar and a big line here. This bottom hook, this line, is the minimum. So it's at 1. That makes sense. The minimum answer was a 1. The highest answer, the maximum, this other hook, is a 10. So minimum, maximum. Those are 2 of the 5 numbers in the box plot. In the middle here, this big black line is the median. So that's if you order the entire data set from high to low or from low to high. You can see what the exact number in the middle of that entire line of all these answers is. This rectangle is formed or represents actually the interquartile range. So that's the middle 50% of the data. That's where the most of the data is. That runs between 2 and 7 for females. So here we have a box plot for females, here for men, and we can already see that on that females have a higher spread, so this entire thing is much higher than males. We can also see that most of the data for females is higher on this scale than males. So there's a difference here in gender. And we can quickly see that in this graph. Another way of looking at it would be to create 2 different histograms, like so. But then you would continually have to look back and forth between all the options. So yes, these two histograms give you the same information, but it's actually a lot more looking back and forth between all the options to see where the differences are. This is much more intuitive and informative. If you consider the information that you want, what is the spread of the data and how you can compare two groups. Alright, last up is the scatter plot. The scatter plot, we use the simple scatter plot, is used when you want to compare two variables that have a interval or ratio measurement level. You use an X and a Y, and then you get a bunch of dots, and it looks like this. You see the opinion that people had on Captain America and the people's opinion on Tony Stark or Iron Man in the movie Avengers. What you're looking for in this kind of plot is whether or not there's any kind of linear relationship between these two scores. So whether or not you can sort of draw a line through this cloud. Well, right now this cloud is not looking very linear at all. The points are all over the place. They're not clustered together in the middle. So right now you can say there's not really a relationship going on here. What would be a linear relationship? Well, that would be something like if people like Captain America more, they're bound to like Iron Man more as well. So if they like one superhero, they like another as well. Or you could find the inverse. If people really like Captain America, they really dislike Tony Stark or Iron Man, you see a sort of negative linear relationship. Basically the plot for Captain America Civil War. You have to choose between one of them. You can't like them both. If you like one, you don't like the other. But we see that in real life is not really the case. So here you have it, all the visualizations that you need to know. The box plot, the pie chart, the bar chart, simple and clustered, the histogram, and the scatter plot. Good luck creating these visualizations by yourself.